Okay, the last thing in this unit is kind of a summary review of everything we've talked about in this sort of application context called bearings. So bearings is a navigational term that is used to specify the location of one point relative to another. That's the important thing. So we're going to say from point A to point B, we're going to give some sort of bearing that describes that. So the bearing is going to be from point O to point P. That is going to be the acute angle, that is important, measured in degrees, not radians, between ray OP and a north-south line. So if you look at where OP is in each of these examples, that's our ray. So here, notice we took the acute route every time. We didn't go, where we have to maybe do more than 180 or something like that. And we're always measuring in relationship to that north-south line. So if you look at these three parts of a bearing down here, excuse me, there's going to be three parts that we need for a bearing. So you're going to see a letter N or S that represents whether we're on the north end or the south end of the north-south line. So if you look, the north-south line is this vertical one, obviously. So if our bearing starts with N, that means we're going to be pointing up on the north-south line. If our bearing starts with S, we're going to be pointing down on the north-south line. Then the second part is going to be the measure of an acute angle, so something less than 90. And then the third part is going to be either east or west, which tells you which direction to go from the north-south line. So, for example, if we look at this first one here, okay, the bearing here is north 43 degrees east. So north tells us that we look up, and then 43 degrees east shows us, you can see the direction the arrow is going here, that we're going to rotate to the eastern side, 40 degrees. Now, you're going to have to remember, how your compass rose works. And I've learned all sorts of different ways. The way I learned it when I was little was never eat shredded wheat. Never eat shredded wheat, going this direction. I know a lot of people learned never eat soggy waffles. Last year I heard never enter Santa's workshop. I thought that one was pretty cute. I like that. So however you remember it, make sure you remember your compass rose. You got to know your difference between north, south, east, and west. To be able to do these bearings problems. So let's look at these examples right here. So we want to use this diagram over here to the right to figure out the bearing of each of these points. So from O to B. So we want to identify first the ray that goes from O to B. So notice that arrow is pointing up. So that tells us that we're going to be on the north end. Then we need the measure of the acute angle from the north-south line towards that angle. So that is going to be 40 degrees. And then it's pointing to the west, so it's north 40 degrees west. That is what we end up with. North 40 degrees west would be the bearing from O to B. Now from O to A, this is a little bit different. Because from O to A, again, this is above that midline, so it's going to be another north. To find the degrees, 20 degrees is an acute angle, but the angle has to measure to the north-south line. So that would actually be 70 degrees. And then because the arrow is pointing towards the eastern side, this one is going to have a bearing of north 70 degrees east. So that one is a little bit different. You might have to do a little bit of work sometimes to come up with your angle. The angle has to be included between the ray from O to A or O to B, whatever you're doing, and the north-south line. We're never going to measure towards that east-west line. So the y-axis is basically what we're thinking. So go ahead and try 3 and 4 really quickly. Pause the video and just do a quick check to see if you've got this. So here are the two answers that I get, and once again, on that number 4 from O to C, don't get distracted by the 75. We need that, but we have to measure from ray OC towards the vertical north-south line. So if you subtract from 90, you get that that is 15 degrees. So as far as what we're going to use this for, it is really not that different from what we've been doing. You might need your SOHCAHTOA problems from 4.8. You might need your law of sines. You might need your law of cosines. It just depends on what kind of triangle you have. Is it a right triangle or is it an oblique triangle? Or it depends on which sides you know based on that information. So they were really nice on a lot of these and gave you the picture, but sometimes they won't. So that's why you got to know what those bearings are. So example 5 says, a boat leaves the entrance to a harbor and travels 25 miles on a bearing of north 42 degrees east. And you can see they've illustrated that bearing right here. So the harbor entrance is this point right here. And then we're going towards the north and 40 degrees to the east. So that's going to be heading that way. And they tell us that they go 25 miles. So that's how we get the length of this side here to be 25 miles. Then they stop. So they stop here at this point. And they turn the boat 90 degrees clockwise. Well, clockwise would be this direction of rotation. So that's where we get this right angle right here. And from there, they travel at a bearing of south 48 degrees east. Now, here's the interesting thing. You'll notice they drew in another north-south line. So every time you stop and create a new starting point, so for example, now we're starting at this purple point right here and heading towards the boat. Now we have to sketch in a new north-south line in order to be able to measure that bearing. So now we're going south 48 degrees to the east. And that is how we come up with this side here of 18 miles. It's a little tricky to come up with these pictures, I'm not going to lie. So you're just going to have to really practice reading those bearings and sketching them out correctly. So the first question is, how far is the boat to the nearest tenth of a mile from the harbor entrance? So if this is where I start and this is where I end up, then that means C here is the value we're trying to find. This is an easy one because we have a right triangle. Anytime you have a right triangle, that's really kind of a gift because that is just SOHCAHTOA. So in this case, it's not even that because we've got these two sides, 18 and 25, so we can just use the Pythagorean theorem to figure out C. So we're going to say that 25 squared plus 18 squared is equal to C squared. You're going to add those together and take the square root of both sides, and you should come out with C is approximately equal to 38.8. And it did say to the nearest tenth of a mile, and don't forget your units, that is 38.8 miles. So that's the distance of the hypotenuse there. Now here's the tricky part. It says, what is the bearing to the nearest tenth of a degree of the boat from the harbor entrance? So we have to think about what that is measuring here. We want to find the bearing from, if we use those same letters that they did on the first example, O, I think it's O for like your point of origin, to a point, that's going to be where the boat is right here. So we want the bearing of this ray right here. That means we need this angle. In order to figure that out, I have to figure out theta so that I can add those two together. I know that that angle is going to be 42 degrees plus theta. Okay? We know that that's what we're going to get. So we have to do a little bit of work to figure out theta. And so we can go ahead and use an inverse function. Again, the 25 and the 18 are the ones that we were given. So referencing from theta, the 18 is going to be our opposite side, and the 25 is going to be our adjacent side. Since C is the hypotenuse, we know that has to be the adjacent. Opposite and adjacent is going to be tangent. So we know that the tangent of theta is going to be equal to 18 over 25. And then we can do the inverse on both sides to get that the tangent of theta is equal to the tangent inverse of 18 divided by 25. Once again, make sure you're in degrees. So we get an angle of, it says to the nearest tenth of a degree, So that's going to be 35.8 degrees for theta. So that means our bearing, if I add 42 to that 35.8, 42 plus 35.8, that's going to give me 77.8 degrees. So we can use the north-south line that's sketched right there because we're starting from point O. So from point O, we're going to the north, and now the entire angle is 77.8 degrees, and that is towards the eastern side. So that is the bearing right there. Sorry, I forgot my stylus at school, so I'm using my finger to write all of this, and it looks kind of ridiculous, but I think it's legible, hopefully. Okay, so there's one example. Let's look at just one more here. So this is kind of a classic problem, and this last one is real similar. So let's just do 6, and then you can look at 7 in the notes if you want to. So 6 says 2 fire lookout stations are 20 miles apart. That's labeled on the picture. That's C. With station B directly east of station A. So that means B has to be to the right of station A, which you can see on the picture. Both stations spot a fire on a mountain to the north. The bearing from station A to the fire is north 50 degrees east. The bearing from station B to the fire is north 36 degrees west. So how far to the nearest tenth of the mile is the fire from station A? That means we want to solve for side B. And you'll notice they were really nice to you on this picture, and they went ahead and calculated these angles. These are the angles that they give you for the bearing, and so that would make a right angle. So if you just subtract from 90, that's how you're going to get the other one. It will help you to remember things like alternate interior angles, things that you know about parallel lines. When you get to these problems, it will help you a lot. So I want to find side B. The question is, do I have a complete ratio? It's not a right triangle, so I know that I can't use my SOHCAHTOA ratios, but I can either do law of sines or law of cosines. I hope that I have a complete ratio because then I don't have to do the law of cosines. And hopefully you are seeing that we do have a complete ratio because we can figure out C. If I do 180 minus 40 minus 54, we get that angle C is 86 degrees. And so we'll use the law of sines. None of this stuff that we're looking at today with bearings is going to be new math. It's all going to be SOHCAHTOA, law of sines, or law of cosines. That's all that's on this test coming up. But the thing that's going to be a little bit tricky is setting up your pictures using the problems, using the directions that you're getting from the bearings now, because that is new. So we can use the law of sines. We don't need to find A. They've only asked us about side B. So we know that we have 20 over the sine of 86 degrees, and that is going to be equal to side B over the sine of 54 degrees. So when we cross multiply that out, we are going to get that B is equal to 20 times the sine of 54 divided by the sine of 86. And let's see, does it tell us what to round to? Tenth of a mile. We're going to get 16.2 miles is the distance of the fire from Tower A. So 7, like I said, is really similar. I think that we've discussed this at enough length by now that you can probably figure out what to do. If you want to try 7 just to see where you're at and check the notes that are posted on the calendar, go right ahead and do that. But so that is the last thing that we're going to talk about. So you will have a math lab assignment over bearings. Everything closes at on Sunday at midnight except for this bearings assignment. This bearings we're going to kind of consider as part of your review because it's really just practicing everything that we've done so far, just using this new type of measurement. So that will not be due until Tuesday night at midnight, and then your test is on Wednesday. So on Monday when I see you guys again, I will have review for you to work on. So you'll have 2 days to finish the bearings assignment and your review to be ready for your test on Wednesday, and then it's spring break. Woohoo! So, I hope you guys have a really great weekend, and I'll see you when I get back next week.